Hello students, welcome back to the class. In the last class, we already studied the experimental setup of the Michelson Morley experiment, isn't it? So in the last class, already we know the experimental setup. So once again, let's see in a brief way. This is the source which is giving the monochromatic light, and this is the semi-silvered glass plate P, and the two mirrors we are taking, one is M1 and another one is M2. So these two mirrors are at the same distance from the semi-silvered glass plate P. Now this is the telescope which is used to find the interference of the light. So these are the instruments we needed for the Michelson Morley experiment. Then as we know, when a light will come from the source S, it will strike the semi-silvered glass plate P, and when it will strike, two cases will happen. One is it will reflect and another one is it will transmit. So whatever the reflected light is there, it will incident on the plane mirror M1 and it will come back to the P. As well, at the same time, the transmitted ray is there, it will incident on the mirror M2 and it will come back to the P. So these things will happen. Now both the rays, when they will come at the point P, here interference pattern will happen. But as we know this, whatever the instrument is there, it is there on the surface of the earth. So as the earth is moving means the setup is also under motion. Okay, so that velocity with which the experimental setup is moving, I am taking it as a phi. So phi be the velocity of this setup, and already we know when light is coming, it is also having certain velocity which is equal to c. So c be the velocity of light and phi is the velocity of this setup. Then when it is moving, so whenever the light reflected from P, instead of incidenting on the mirror M1 at B, it will incident on the B dash, because of the moment of the setup, isn't it? So as it is moving, instead of going the ray here, it will go like this. So because of the motion of this experimental setup, so that time the mirror M1 will shifted to M1 dash. At the same time, the M2 mirror will shifted to M2 dash and P will be shifted to P dash. So because of the motion of the setup. So already we studied these all the things in the last video. Now when it will incident on the plane mirror B dash, it will come back in this way and it will incident to P dash. And at the same time, the transmitted ray from A, it will incident to A dash. Instead of A, it will incident to A dash and it will come back and it reaches to the point P dash. Means the reflected ray back from the mirror M1 and transmitted ray back from the mirror M2, it will both will coincident at the point P dash. So this one we studied. So if you have any doubts about the setup, just see my last video, so you will come to know that things. And in the today's class, we are going to have the derivation of the Michelson Morley experiment. So nothing but we are going to prove the velocity of light is same in all the cases. We know whatever the medium you take, whatever may be the situation or whatever may be the time, at all these situations, the velocity of light is equal to c, which is equal to 3 into 10 raised to 8 meter per second. Already we know. Then from this experiment, we are proving the c value remains constant, isn't it? So let's go for that. Then to prove that, the first thing we should prove, when a ray is reflected and coming back to the same semi-silvered glass plate, so how much time it had taken, and the transmitted ray is coming from P and again it is incidenting on P dash, it will take certain time. So the reflected ray and the transmitted ray are taking certain time, and that time in both the cases they are not taking the same time. The time will be different, means the time difference we will get. So let I will take T1 be the time taken by the reflected ray to come back to the P dash, isn't it? So from P, the light ray will go, it will strike to B dash because of the moment of the experiment, and then it will come back to P dash because it is a mirror. So reflected back to the what? P dash. So to cover this path it will take certain time, and that is what? T1. So that time is nothing but T1. At the same time some ray will transmitted, and that transmitted ray will incident on the A dash and will come back to P dash. From P they will come, but to A dash they will incident and they will come back to what? P dash. So this also they will take certain time, and that time we denoted by what? T2. So I hope you understand T1 and T2. T1 is the time taken by the reflected ray to come back to the semi-silvered glass plate, and T2 is the time taken by the transmitted ray to come back to the semi-silvered same glass plate. So now we should find these two time difference. So nothing but what? T2 minus T1. So we are going to find the T2 and T1 value calculation. So first I will calculate T1, then we will calculate T2, then we can get the what? Easily the subtraction of those two things. So let's calculate the T1. So T1 is equal to, I will take when a ray will come out from the semi-silvered glass plate and it will incident to the B dash. So for this let the time taken by the ray is T I will take. So to go it is taking the time T, and again to come back the same time it will take, because both the distance are same. The distance changing, time will change, but as the same distance the light ray is covering, to go and to come back same time it will take. Okay, so while going how much time it had taken? T, and while coming back how much time it had taken? Again T. So if you add these two things, while going and while coming back, so if you add you are getting the what? The total time taken by the reflected ray to reach to the what? P dash point. So T1 is equal to T plus T, which is equal to 2T. T1 is equal to what? 2T we got. Now how to calculate this T? I want to know this calculation of the T. So for that I will consider a right angled triangle, PB dash C. I will consider PB dash C triangle to calculate the time. So from the Pythagoras theorem, if you apply for this triangle, you can come to know this square divided by this square plus this square. So I will write that one. That is PB dash square is equal to P into C square plus B dash into C square, isn't it? So now I will substitute all these values. As we know, B dash C distance is equal to what? BP distance. So both the distance are same. As it is there at a distance D means this is also having the same distance, that is what? D. So we got the B dash C value here. Now I want to calculate this value and this value. Okay, so as the light ray, this is nothing but the light ray. So when it is moving, it is having the velocity c, and how much time it is taking? It is taking the time is equal to t. So the light ray having velocity this much and taking this much time, then this distance is nothing but velocity into time. So already we know velocity is equal to displacement divided by time, or you can take distance divided by time, because both are having the same magnitude. So distance is equal to velocity into time. So what is the velocity? C, and how much time it had taken? T. So this gives the distance value. This is giving the what? Distance value. So that's why P B dash value becomes equal to what? C into T. Then now I will go to the PC value calculation. So PC is nothing but the moment of the experiment. So here P to C, the body is moving, means the experimental setup is moving. So already we know the setup is moving with how much velocity? That is nothing but v. So again it is taking the same time, nothing but a t, to move from one point to the another point, from light to go here to here, t time, and also the same time it will take to go from P to C point. So now to calculate this distance, again velocity into time we should use the formula. So velocity is what? The experimental setup velocity is v, and the time it had taken t. So that distance becomes what? V into t. The light ray having the light ray covered the distance c into t to move from P to B dash point. At the same time, the setup had covered the distance V into T to move from what? P to C. Just by using the formula, distance is equal to velocity into time. So we got all these three values, isn't it? So substituting in this equation, we can get PB dash square. PB dash means this is C into T. So nothing but C square into T square we will get, which is equal to P into C means V into T. So that square means V square into T square plus B dash C. So B dash C is nothing but D, the distance. This is distance because both are having the same distance. So that is D means square means it is equal to D square we got. Now I will transfer this V dash T square term to this side. So we got D square is equal to C square T square minus, so when it will go, it becomes minus V square into T square. We got the equation. So let's take T square common here. So if you take T square common, what is remaining? C square minus V square. T square is common in both the things I taken outside. So it giving C square minus V square, which is equal to D square is equal to V got. But our main intention is we are going to calculate T, because if you know the T value, no, we can readily get the what? T1 value. So to calculate T, keep this T square here and transfer the C square minus V square term to this side. So it gets divided because here it is multiplied. So now we are getting T square is equal to D square divided by C square minus V square. So we got this value. Now taking square root on both the sides. So if you take the square root of T square, it becomes T, and square root of this becomes D square. Square root will be D will get divided by square root of C square minus V square. Just by taking the square root on both the sides, you got the what? T value is equal to D divided by square root of C square minus V square. We got the value. Now in this value, I will take T is equal to D divided by C square. I will take outside. So if C square, if you are taking outside, it becomes C, because from the square root it is coming. Okay, so C will come, and what is remaining? So inside the bracket you have taken C square outside, so 1 is remaining here, and minus C square is not there here term, but even though we taken outside, that's why it becomes what? V square divided by C square we will get, isn't it? So taking C square common from the what? Square root, it becomes a C. Here 1 will be remaining, and minus, as no term of the C square is here, we are getting V square divided by what? C square. So finally we got the what? T value. So let's substitute in the equation. We will get the T1 value. That's why T1 is equal to T1 is equal to, as it is equal to 2 into T, which is equal to 2 into, what is the T value? D divided by C into the square root of 1 minus V square divided by C square. You got the value, which is equal to 2D divided by C. I will write as it is, and this is like 1 minus V square divided by C square raised to 1 by 2. 1 by 2 it is. But if you take to the numerator, no, it becomes minus 1 by 2. So I will take to the numerator 1 minus V square by C square as to what you will get? Minus 1 by 2. Because it is in denominator. If you take the numerator, no, it becomes minus 1 by 2. So which is equal to 2D divided by C. 2D divided by C. And we know 1 minus, we know the thing, that is 1 minus x raised to minus 1 by 2. 1 minus x raised to minus 1 by 2 always gives the value which is equal to 1 plus x by 2 plus x by 2 whole square plus dash dash. Means this series, if you do the calculation, no, it is giving the value like 1 plus x by 2 plus x by 2 whole square. But as these higher quantities became too much small, we will neglect all those quantities. So only what we will get? We will get 1 plus x by 2. Understanding? So here also same term is there. 1 minus x raised to minus 1 by 2 giving 1 plus x by 2. So 1 minus v square by c square means it is acting like a x. Rush to what? Minus 1 by 2 is there. So if you apply the same thing, 1 plus x by 2. So substitute that value. So what will get? 1 plus what is x? X is v square by c square, but x by 2 is there. So 2 term will come by applying the rule. So we got T1 is equal to 2d divided by c into the bracket 1 plus v square by 2 c square. We got the value. So let T1 is calculated. Now what to calculate? T2 we are going to calculate. Okay. So same thing we will move for the T2 calculation. So T2 means, as I already said, this is the time taken by the transmitted ray. So when the light ray will transmit and to come back it will take certain time, that is what T2. So if you see, first the ray will come from the P and it will incident to A. So if the situation, if you are getting the light ray is coming the positive direction of the x-axis, at the same time the whatever the setup is there, it is also moving along the positive direction of the x-axis. And light ray is moving with how much velocity? That is c. And the setup is moving with how much velocity? V. And both are moving in the same direction. That's why these two, the relative velocity becomes is equal to what? C minus V. The relative velocity become equal to C minus V, because both are in the same direction. If both are in the opposite direction, plus V we would have get. But as they both are in the same direction, we are relative velocity becomes what? C minus V. Now when light ray will come from P and incident to E, so what is the distance covered? So the distance covered is again nothing but D, because both are at the same distance. That's why the distance is D, and to move how much velocity it is having, that is equal to C minus V. So first case, the transmitted ray when it moved from P to A, the distance covered is D and the velocity is C minus V. But when it will strike, it will, instead of A, it will strike to A dash because of the moment, and it will return back to P dash, means same distance it will cover. Is it? Because both the distance are same, because the mirror M2 is at a D distance from the semi-silvered glass plate. So when it will displace from P to P dash, at the same time A will displace to A dash. So that's why they are covering the same distance. But when it will come back from the A dash, no, this is the ray coming back, means I will show the direction here. This is the ray coming back, but even though the setup is moving along the positive direction of the x-axis only, means like this it is moving. So here C velocity and V velocity. So what would be the relative velocity? That is C plus V we got, because both are in the opposite direction. Now to go from P to A, it has covered D distance with the velocity C minus V, but while coming from A dash to P dash, coming back, the transmitted ray while coming back covered the same distance, but the velocity is C plus V. C plus V you got, means what would be the time taken? What would be the time taken to go from P to A? We know velocity is equal to distance divided by time, means time is equal to distance divided by velocity. So from that, if you divide D divided by velocity, it is giving the what? T time to go. And while to return back, what will be the time? That is D divided by C plus V, according to the formula, distance divided by velocity. So to go from P to A, P to A, it had taken the time is equal to D divided by C minus V, and to come back from A dash to P dash, it had taken the time D divided by C plus V. This is the time, two different time it had taken. So again we are calculating the what? T2, means the while going and while coming back time we should add to each other. So that's why we are adding both the things, while going this much time and while coming back this much time. So if you add these two time, no, it will give the total time, that is equal to T2. So add both the things. So what we will get? We'll get D divided by C minus V plus D divided by C plus V. We got the equation. So solve the equation. What will be the LCM? LCM is C minus phi into C plus phi, means here C plus phi we will multiply and here we will multiply with the C minus phi. So multiplying, what you will get? D into C plus D into phi. D you are multiplying, plus here if you multiply, what you will get? D into C minus D into phi you are getting, isn't it? Just by taking the LCM, which is equal to plus dV minus dV get cancel, dC plus dC will be remaining. So that is equal to 2D into C divided by, as it is in the form of A minus B and A plus B, we can write it as A square minus B square, means C square minus V square. We got the equation. Now again here 2DC divided by C square I will take outside. So C square if you take outside, here 1 will be remaining, minus here V square by C square will be remaining by taking C square outside. Now 1 of the C get cancelled, so we are getting is equal to 2D divided by C, 2D divided by C, and this is rush to 1 is there. So when it will go to the numerator, it becomes minus 1. So what we are getting? 1 minus V square by C square rush to minus 1. We are getting minus 1 quantity. Now as it is in the form of 1 minus x raised to minus 1, so already while I told about the 1 minus x raised to minus 1 by 2, like that 1 minus x raised to minus 1 gives the value of, it is giving the values of 1 plus x plus x square by 2 factorial plus dash dash, like that it will be giving. So 1 minus x raised to minus 1 giving the value like 1 plus x square by 2 x square by 2 factorial. So again the here terms we will neglect. So what will be the value? Only 1 plus x we are getting. Here 1 plus x by 2 we are getting, because minus rush to minus 1 by 2 was there. Here minus 1 is there, so 1 plus only x we are getting, divide by 2 will not be there. So same thing if you apply here, this is like 1 minus x raised to minus 1, so we are, what value it gives? 1 plus x. So substituting that we are getting t is equal to 2d divided by c as it is. This value becomes what? 1 plus x. So x is nothing but what? 1 plus v square by c square. So we got the T2 value is equal to 2d by c into the bracket 1 plus v square by c square. That is the value. So now we got T2 value as well as T1 value. So let's take the subtraction of those two. T1 also we are having, T2 also we are having. So let's subtract both the things. So what we will get? T2 minus T1, because T2 term is larger. If you see both the things, so T2 term is larger, that's why T2 minus T1 we are getting. Here divide by 2 is there, means it will be less as it is divided. So T2 value is what? 2d by c into the bracket 1 plus v square by c square minus this becomes 2d by c into the bracket 1 plus v square divided by 2c square will be there, is it? And which is equal to 2d by c, common is there, I will take outside. So 2d by c I will take outside. So what will be remaining here? 1 plus v square by c square will be remaining, minus 1 and minus v square by 2c square will be remaining, isn't it? And plus 1 minus 1 get cancelled, that is equal to 2d by c into the bracket as like a v square divided by c square minus v square by 2c square. So LCM will be 2c square, means here you will multiply with 2. So 2 v square minus v square becomes what? Yeah, I will write 2 v square minus v square divided by what? 2c square. Is it the LCM? So from the LCM we got this value, which is equal to 2d by c into the bracket 2v square minus v square becomes v square divided by what? 2c square we are getting, means 2 get cancelled, and if you write the time difference is equal to what you are getting, which is equal to dv square divided by c cube. dv square divided by c cube we are getting, because c into c square becomes c cube here. This is the time difference we got. As deflected ray and transmitted ray both are taking the different time. That's why time difference we got. But if you see the path, the distance covered, that is also different, isn't it? The reflected ray covered the distance p, b dash, p dash, and the transmitted ray covered the distance p, a dash and p dash. Okay, so if you see these two things, the transmitted ray covering more distance than the what? The reflected ray to come back. That's why there should be path difference also there. And from this time difference, path difference easily you can calculate. That is equal to, path difference is equal to, path difference is equal to c by lambda into time difference. C by lambda into what? Time difference. And already we are having the time difference this much. So I will directly substitute. That is a d v square divided by what? C cube you got. Now cancelling the terms. What will get? One of the c get cancelled. So you will get a d v square divided by lambda into c square. The path difference to cover the rays you are getting is equal to how much? D v square divided by lambda into c square. This is the case when the setup is moving along the positive direction of the x-axis. Like this, the setup is moving. But if you turn the setup through the 90-degree angle, same setup I will turn to the 90-degree. Then also we can find the path difference. Okay, so that time the path difference becomes, as we are changing the direction here, so it becomes what? Negative we will get. That is what? Minus d v square divided by lambda into c square. We got minus d v square divided by lambda into c square. Okay, so if you observe the path difference, both the side you got the same value. Only the direction is changing. Okay, so as the magnitude is same, means it is indicating that the light ray is moving with the what? Same velocity. The light ray, the negative result suggests that the velocity of a light is what? In same for both the cases. So this is what the derivation of the Michelson Morley experiment, which is there for 10 marks. So this experimental setup and the derivation part, if you make no, you are getting totally 10 marks. Okay, so very easy experiment it is. Once again go through the thing. So in the experimental setup, S is the source, P is the semi-silvered glass plate, M1 and M2 are the two mirrors, and T is the telescope to measure the interference of light. Then when a light ray will come out from the source, it is incidenting a semi-silvered glass plate P. So some of the ray will be reflected and some of the ray will be what? Transmitted. Then the reflected ray will incident on B dash instead of B, because the experimental setup is moving with the velocity v. This whole setup is moving with the velocity is equal to what? V, because it is there on the surface of the earth. And the ray, when it will incident on mirror M1 dash, it will come back to the what? P dash, because of the moment. For all the reason is moment only, the moment of the setup. Then the transmitted ray will come out from P, and instead of incidenting at A, it will incident to A dash and it will come back to what? P dash. So these are the path covered by a reflected ray and the transmitted ray. So just from the figure we can conclude that the transmitted ray is covering more distance to come back to the P dash point than the reflected ray to come back to the P dash. That's why they are taking different time to reach the same point, that is P dash. So that's our aim. That is what? Time difference T2 minus T1 we should calculate. So to calculate this T2 minus T1, first T1 we will calculate. That is, we know T1 is equal to, while moving T time and while coming back T time. So both the time same. That's why T plus T is equal to 2T. And to find that this time we will consider a triangle, right angle triangle P B dash C. So from that triangle apply a Pythagoras theorem, substitute all the values. So I said already distance is equal to velocity into time. Again distance is equal to velocity into time. Light ray velocity is c and the experimental setup velocity is v. So we had taken different velocity here. Substituting all those values, we got the t value is equal to this much. So substituting in the first equation, we got t1 is equal to 2d divided by c. It will go to the numerator. So we will get into the bracket 1 minus v square by raised to minus 1 by 2 we are getting. It is in the form of 1 minus x raised to minus 1 by 2, which value is equal to 1 plus x by 2. 1 plus x by 2. So we got the t1 value. Next our job is to find the what? T2 value. So as the transmitted ray moving in this direction, the setup is also moving in this direction. So the relative velocity becomes c minus v. But it is covering the d distance only. And transmitted ray cover the same distance, but setup is moving like this and ray is coming like this. That's why the relative velocity becomes what? C plus v. That's why while going, the time taken is d divided by c minus v, and while coming back the time taken is d divided by c plus v. But by the formula time is equal to what? Distance divided by velocity. So we got and we applied and taking the LCM c minus v and c plus v and substituting the values, you got 2 dc divided by c square minus v square. So here again c square you take common, cancel the terms, you are getting 2d by c, you transfer to the numerator, it becomes minus 1, and this quantity value becomes what? 1 plus x, that is 1 plus v square by c square. So both the things we got. From that t2 minus t1, do the calculation and we will get 2d divided by c, and which is 2d divided by c into v square by 2c square we will get finally. Just subtracting with the same method, with the easy method. Okay, so 2 get cancelled, you are getting d v square divided by c cube. This is the time difference for the reflected ray and the transmitted ray. To go and come back, to go and to come back. So there will be different time they are taking. That will come early than the transmitted ray, isn't it? So now if they are taking different time to cover the distance, means the distance also different. That's why the path difference we will calculate by using the formula c by lambda into time difference. So substitute the time difference value, you will get certain value. So same setup, if you turn through the 90 degree, like this, you are getting path difference is equal to minus of same quantity. Same thing we will apply, we will get this result. So the negative result suggesting that the velocity of light, because only direction is changing but same distance it is covering, isn't it? Along this direction, this is the distance, and perpendicular if you keep this much distance it is covering. Okay, so as the direction is changing but the light ray is covering the what? Same distance in all the cases. That's why it suggests that, or it concludes that the velocity of the light is constant in all the medium and in all the situation. So this is what about the Michelson Morley experiment, which is very important for the 10 marks. Okay, so I hope you understood all the things and all the mathematical steps what I had used. Okay, so next class we will study the further thing. Okay, bye.